Okay, this video is the second day of section 2.2 in your textbook. Yesterday we talked about using inverse matrices to solve matrix equations, and today we're going to talk about using inverse matrices to solve systems of equations. So please pause the video and work on this warm-up assignment. Okay, to find the inverse of a matrix, the first thing we want to do is find the determinant. So we are going to remember these are A, B, C, and D. So the determinant is going to be AD, so 8 times 1, which is 8, minus BC, negative 2 times 6, which is 12. So the determinant is negative 4. Alright, now we're going to take the 1 over the determinant, and we're going to switch the places of A and D. So this is going to be 1 and this is going to be 8. And we're going to negate B and C. So this will be 2 and this will be 6. When I distribute the 1/4, I find the inverse of this matrix is negative 1/4. Negative 1/4 times 2 is negative 1/2. Negative 1/4 times 6 is negative 3/2, and negative 1/4 times 8 is negative 2. Because I'm not going to use the inverse to immediately solve something, I am going to reduce all of my fractions. Number 2 says solve the matrix equation. Well, here we have matrix A, and it's matrix A times matrix X equals, we'll call this matrix B. If you remember from yesterday, we cannot divide by matrix A. What we have to do instead is multiply both sides times A inverse. So now our matrix equation will be A inverse times AX equals A inverse times B. And our goal first is to find out what A inverse is. So here we go. A inverse, well, we need to start with 1 over the determinant. Now the determinant is going to be 4 times 2 is 8 minus 5 times 2, which is 10, so 1 over negative 2 times, I'm going to switch A and D, and I'm going to negate B and C. Okay. Now when I distribute, I'm just going to be really thoughtful about it. I'm going to have negative 1, positive 1, negative 5/2, and negative 2. Alright, so now to solve for matrix X, I need to do A inverse times B. Alright, so here we go. A inverse is negative 1, 1, negative 5/2, negative 2, times matrix B. So this is going to be 2, negative 2, 1, 1. Now when I multiply matrices, I do them row by column. Remember, this is A inverse, this is B. So negative 1 times 2, which is negative 2, plus 1 is going to give me negative 1. Now I'm going to do first row and second column. And that will give me 2 plus 1, which is 3. Now I'm going to do the second row and the first column. Well, that's going to be negative 5 and negative 2, which gives me negative 7. And then positive 5 and negative 2, which will give me a positive 3. Wait a minute. I screwed something up. This is supposed to be positive. Positive. You probably already saw that, and you're like, Mr. Josh, you got a mistake going here. So that's going to change to just this last number. So positive 5/2 times 2 is 5. minus 2 gives us 3. And then 5 halves times negative 2 is negative 5. Minus 2 gives us negative 7. Okay, here are the answers to last night's homework. They were on Edline last night. If you have any questions, we will talk about them in class tomorrow. Alright, before we look at using inverse matrices to solve systems of equations, I want to take a look at just solving for x and y when they're within a multiplication problem. I see that I'm multiplying this 3 by 3 matrix by this 3 by 1 matrix. And x is in the third row, first column here. So what I'm going to do is I'm going to see what happens if I multiply the first row and the first column. I should get negative 5. So 1 times 2 plus 1 times negative 1 plus 3 times x equals negative 5. So that will be 2 minus 1 plus 3x equals negative 5. Well, this becomes 1 plus 3x, and that means that x equals negative 2. Now, y is located in the answer, and it's in the second column. I'm sorry, the second row. So to get the second row and the first column from the answer of multiplication, I'm going to need the second row and then the first column. And I know that x is now negative 2. So I'm going to do 2 times 2 plus negative 1 times negative 1 plus, and now instead of 4x, it's going to be 4 times negative 2, and that will equal y. So that will be 4 plus 1 minus 8, which is negative 3 equals y. Alright, take a moment. I want you to pause the video, and I want you to work on number 2 by yourself. Okay, I'm going to solve for x first. X is in the first row, second column. Honestly, it makes no difference that it's in the first row because I'm multiplying this matrix times this one. And I'm going to use a row from this matrix and a column from this matrix. So I'm going to use the second column. I'll use the first row and the second column. So the first row and the second column match up with 9. I'm not going to use the second row and the second column because that matches up with y, and I don't know what that is yet. So we're going to have 2x plus 3 times negative 1 would be minus 3. 1 times 2 is 2, and that equals 9. Well, that means 2x minus 1 equals 9, and that means that x equals 5. To find y is in the second row, second column of our answer. So I'm going to use the second row, oops, that's 5 is circled, and the second column. So negative 1 times x, where x is 5, is going to be negative 5. 4 times negative 1 is negative 4. 5 times 2 is 10. And that equals y, and negative 9 plus 10 is 1. Alright, the real goal today, however, is to talk about how we take a system and use matrices to solve it. Take a minute and write down number 1. 2x plus 3y equals 7. 4x minus 4y equals 4. Now remember, guys, this is a system. What I'm going to do is take my system and I'm going to rewrite it with matrices. The first matrix I'm going to write is going to contain all the coefficients. We'll call that the coefficient matrix. We're going to multiply the coefficient matrix times our variable matrix. And that will equal our answers. Take a second and jot this down because I'm going to erase it to make room. Pause the video if you're not done. Alright. So what I'm going to do first is pull out my coefficients. My coefficients are 2, 3, 4, negative 4. And I write them exactly as I see them in a 2 by 2 matrix. Now my variables are x and y. I'm going to write them in a 2 by 1 matrix, one on top of another. X, y. Then I'm going to write my answers just as they look, 7 and 4. Now I want you to watch what happens. I've written this as the multiplication of two matrices. If I were to multiply first row times first column, I would do 2 times x plus 3 times y, and that would equal 7. Hey, guess what? That's what it is. 2 times x plus 3 times y has to equal 7. That's our first equation. Okay, we are going to use matrices to solve this system. We're going to call our coefficient matrix matrix A. We're going to call our variable matrix variable matrix. And we're going to call 7, 4 matrix B. Now, to solve for matrix XY, we need to get rid of the A. And just like we learned yesterday, we can't divide by matrices. So what we need to do is multiply by their inverse. So the first thing we need to do is find matrix A. And now you can see that this is starting to look a whole lot like yesterday's lesson. So let's find A inverse. And once we do that, we can do A inverse times B. So A inverse, first we need 1 over the determinant. And here we have a determinant, negative 8, and minus 12 is going to be negative 20. We're going to switch A and D. We're going to negate B and C. Now, when I distribute my negative 20, I am not going to reduce any fractions because this problem is not asking me to find matrix A inverse. It's asking me to solve for XY using an inverse matrix. If I don't reduce my matrices, the fractions within my matrices, the arithmetic is going to be a lot happier, I promise. Watch what happens. I know 4 over 20 reduces to 1/5. But I'm thinking ahead, and I'm thinking if I'm going to have to multiply this row by this column, that means eventually I'm going to be adding fractions. And isn't it nicer when my fractions have common denominators? Yes, it is. So here's A inverse written in black. And to find XY, we need to do A inverse times B. So I'm just going to write B right next to it. 7, 4. Alright, so we're going to do the first row of A inverse times B. So, let's see. 4/20ths times 7. I'm going to do my scratch work over here. So that will be 28/20ths. I'm not reducing. Watch, there's a reason. 3/20ths times 4 is 12/20ths. Now, I have to add these together. This right here, folks, is why we are not reducing these fractions, because now I have to add them together. Cha-cha! They already have common denominators. How awesome. 28 plus 12 is 40. 40/20ths gives us an x value of 2, because remember, this is xy. So, we've got x equals 2. Ooh, that's messy. And now we're going to find y. Second row, first column. So 4/20 times 7 again is 28/20. Negative 2/20 times 4 is going to be negative 8/20. Hey, guess what? Common denominators. 28 minus 8 is 20. And 20 over 20 is 1. And that means that y is 1. Awesome. Take a moment, write down anything else you need. I'm going to do one more with you, and then you're going to do number 3 on your own. Number 2, the first thing I'm going to do actually is erase all of this lovely work to make room. Sorry, lovely work. Bye-bye. So for number 2, the first thing I'm going to do is I'm going to write my coefficients. 1, 1, 3, 2, times my variables, x, y, equals our two answers, negative 21, negative 15. This is A, this is xy, this is B. To find xy, again, we're going to multiply both sides times A inverse. So, here we go, A inverse. That's going to be 2. Ooh, this one's excellent. Look what happens. 1 times 2 is 2. 3 times 1 is 3. And when I subtract, I'm going to have negative 1. So 1 over negative 1. I'm going to switch 2 and 1 and negate 3 and negative 1. And that gives me an inverse of 3, 1, negative 1. That's A inverse. I'm going to multiply that times matrix B, which is negative 21, negative 15. So let's think. Negative 2 times negative 21 is 42. 3 times 15 is negative 45. That means that x is negative 3. So now I'm going to do 1 times negative 21. Well, that's negative 21. I'm going to do negative 1 times negative 15, which is positive 15. When I add those together, I get negative 6. So that means x is negative 3 and y is negative 6. What I would like you to do is to find a partner and do number 3 using the same method. I'm going to give you a little warning and let you know that number 3 is going to have a lot of fractions in it. Don't reduce your fractions. Leave them unreduced in your inverse so that when you go to do A inverse times B, you will have common denominators. Who cares if your determinant is like 1,000,000? So what? That just means all your denominators will be 1,000,000, but then when you multiply, they all add together very nicely. So find a buddy, pause the video, work on number 3. I'm going to release the answers, so when you unpause the video, they'll be waiting there for you. For number 3, you should get x equals 25 and y equals negative 50.
Miss Burdett.